Hey, welcome back to the channel, everyone. Today we're going to touch on domains in functions, how to find them, and how to really find the outliers and what cannot be a domain. Okay, so what exclusions do we have? That's really what we're looking at here. Okay, so as a piece of our information, we are talking about two sets here. We're talking about the domain of a function, okay, and the other wording that comes with that domain is a range. All right. So when we talk about domain, we are talking about the x values, or another way to refer to that would be the input. Okay? This is what you've heard before in prior years in math and also science as well. Okay? So you may refer to this domain as the input or the independent variable, which therefore the range, we're talking about this f of x value. Okay? Otherwise could be known as y, it could be known as the output, or it could be known as the dependent variable. Okay? All of these words are interchangeable here. All right? So when we're talking about domain and range, we are really talking about those x, and in this case, because I have f of x, we're going to use f of x in our table. Okay? So my question becomes, with all of these, in any of these graphs that we're going to make, are there any domains, any x values here, and I'll label that, are there any domains that are not allowed, not allowable, okay? Meaning they're an exclusion. I'll touch on that in a minute, okay? So here's our domain, here's our range. We are really focused on here and saying, do any of these x values give me a solution to my y value, my range, where it does not have a solution, okay? Well, if I look at a very basic example here, okay, I can see that really, if I substitute in x is 1, 3 times 1 is 3, minus 4 is negative 1. If x is 2, I have 6 minus 4, which is 2. X is 3. I have 9 minus 4 is 5, and so on and so forth. If I went backwards, x is 0, I get negative 4, and then I would continue that pattern. If I were to use any type of number, this right here would actually create what's called a linear graph. And actually, we have all real numbers for our domain, okay? So in reality, our domain is going to have a solution where all real numbers, that's a symbol for all real numbers will work. So it wouldn't matter if I would substitute in a negative 1, I could get that to work, okay? Make it negative 7, I could do 1/2, I could do, in reality, I could use pi, and I would still get a solution there. So I'm still getting a real number for the solution. My domain is okay, all right? Now, in really looking for exclusions, here's the one that we cannot have. We cannot have any number divided by 0. This is a big no-no, okay? If I try to divide any number by 0, I'm not going to get a solution. I'm actually going to get something that is known as the null set, which could be defined as an undefined solution. It doesn't exist, okay? So that's known as the null set, and it is undefined solution. Case in point, if you were trying to divide 2 by 0, if you're telling me it's 0, just work backwards with multiplication here. 0 times 0 would have to get 2, which we know in any case, anything times 0 is going to be 0. So there's no way for this to occur and actually work. So we are not allowed to divide by 0. So this is really what we're focused on. Will we get a denominator of 0? If the answer is no, then we are going to have a domain, of all real numbers. So I look down here, even though there's a fraction, I look to my denominator and say, does 9 equal 0? Well, in this case, it doesn't. So in reality, again, my domain is going to have a solution of all real numbers. And that's how we would notate it, okay? So we put a brace around what our solutions are, okay? All right, so I continue on. Now I have some variables in my denominator. So this is really where I have to focus. We are only focused on the denominator here when we're finding our domain. So what exclusions can we have, okay? Well, I said my denominator cannot equal 0, okay? So if I substituted in a 1 here for x, I would get a solution. So x could be 1. Could x be 3? Absolutely. Could x be negative 2? Absolutely. It's not 0. In this case, the only one I cannot have is 0. So my exclusion, my domain, would be all real numbers with the exception of not equaling 0. So I would have all real numbers. However, if I substitute a 0 in here, I can't divide by 0. I'm not allowed to have that. There's my domain. Okay? The final one over here is now a little bit of an equation we have to solve. Okay? So again, I'm just focused down here. I don't care what's in the top. I care about what's in my denominator. All right? And I said I'm not allowed to get a 0 in my denominator, meaning I'm going to set an equation here and set it equal to 0. This is the fast way that we solve these. Okay? So it doesn't matter what's in the numerator. We take our denominator, set it equal to 0, and then we just solve the equation. So because I was adding 12, opposite operation is to subtract 12 from both sides, and therefore x is equal to negative 12. So what does that mean? That means all other solutions will be a part of this, with exception to negative 12. So x cannot equal negative 12 in this case, because if I substitute it back in here, negative 12 plus 12 will get me that magic number 0, and I cannot divide by 0.